everyone, welcome back to Abrar Knowledge channel. This is a part 2. I will be making it on Lean Six Sigma 100 marks model question paper. This will be very handy for people who are going through green belt certification or black belt certification on Lean Six Sigma. This will be very handy for all of you. I have already done part 1 and very good responses we have received on part 1. And in order to bring few more set of questions, this part 2 was being created. So let's go, and it has the multiple choice question and many tab question. The multiple choice questions, the first question, here we go. Identify the tool. On the left side, we have one tool. Another side, you have one tool or plot, right? So the left side is what is the name of it, and right side, what is the name of it. So we can say the left side, it has given more detail like R square value, standard deviation, R square adjusted and all that. This is typically happens in regression. On the right side, this is a scatter, which does not give the equation, which does not give the R square value on the plot, right? Therefore, my answer is regression, and on the left side and the right side is scatter. Next question. Why not averaging is not useful in P chart? For example, let's say you have P chart is proportionate chart, right? So 300 samples, 5 scrap. What you do? 5 divided by 300, you get this value. And then can we do like this? We have 5 slots or 5 set of samples. Can we do an average? No, we should not do an average. Must not average because denominator are different, because your scrap is different and your sample size, that is also different. That's the reason you should not do average. However, if you wanted to do, what we need to do, add this up. For example, all these samples is 3,250, all the scrap is 17, then you can do it. This is the best one. That's what the P chart also does use it, right? So we should not average it in a average it like this, but we should average it by summing up all. Let's go to, this is true, because the question was on can we do, why not averaging is not useful. So the answer is this one. So correlation, and here they have given, please evaluate R square. R square, they have given 94%. If it is 94%, it is says strong, very strong correlation. And then you have next one, ANOVA gives dash. Does it give median? Does it give mean? Does it give mode? It gives mean. Whatever, for example, vendor A mean, and this is the graph to interpret it. So dark blue is called mean, and this is whisker, the starting point, end point, and all that. So basically, it gives mean. So P chart is used, when to use P chart? You all know that P chart is used for defective, and when you have a variable sample, and you can use the P chart. That's the reason you will have a provision like this in the mini tab, so that you can insert the column, the sample column also as well. So therefore, when defective, when variable samples are being formed. Let's go to the next question. When the recommended action to be taken, and in this case, the RPN is higher in the second place and fourth place. So we need to take recommended action. And let's go to the next one. Design of experiment. If the number of people increase by 1% when the outside temperature is hot, the performance drops by 4% when the outside temperature is cold. Then the performance is not impacted. What plot we are talking about? So we are talking about interaction plot. So when defective 20 sample to 8,000, what is the DPMO? I have also given this in one of the video, how to calculate using the Six Sigma calculator. So the question is, defective is 20, sample is 8,000. Let's go and feed that value. Defective, this is a discrete one. Defective is 20, sample is 8,000. So 2,500 is the DPMO, right? So what I'm going to do is I'm going to select 2,500. Let's go to the next question. MSA GRR result as follows. It has given a NDC value, number of distinct categories, 1. If it is so, we have to reject it because more variation, we need to see where the variation is there. See, you can see here repeatability has got more variation. Okay, and let's go to the next question. If DPMO equal to 5,555, then what is the ZST, short-term performance, right? Also called sigma. So you just need to have a fill this value. 5555 and enter it. 4, yeah, ZST value equal to 4.0. So I will just give alt tab. I'll come back. I'll give this one 4.0. Let's go to the next question. And generally drop the overlay on the same graph in the mini tab. How you do it in the stat menu or in the graph menu. This is possible only with the graph menu. If you wanted to overlay the graph like this, you can do it. CPK acceptable limits are industry 1.33 and automotive industry 1 minimum 1.66, that is equal to 5 sigma. Next question is yield equal to 93.3. What is a process sigma? Let me go to the calculator again, and I'm giving like yield 93.3, 93.3, and so it's 3 sigma. If the yield is 93.3, it refers to 3 sigma. Farthest away or the away from the dot slope mean, the R square value will get reduced or impacted. Whereas the closest to the slope on the slope, it gives the better R square. For example, when you say in this overall, the R square is good because it is 0.9. It is very good, a strong correlation between weight and height. However, if assumingly if the dot is very far, let's say instead of here it is here, and that means R square will get impacted. So it's a true scenario. And control plan is necessary as same as the FMEA. Control plan provides reaction plan and the countermeasure. So this is a scenario. Yes, it is true. Control plan is also mandatory because it gives a reaction plan. Why do black belt professional do need to know six thinking hat? Six thinking hat very famously written. I have also covered in the YouTube. It's called Edward de Bono, a very wonderful author. So here they have given the options. People are different, must know the tactics to deal the people. Dr. Edward de Bono developed this technique for helping teams to stay focused on creative problem solving by avoiding the negative and group argument. Theme to enhance team creativity and evaluate ideas can be applied during the solutions or idea generation, all given options. So the answer is all given option. So usually world-class benchmarks, cost of poor quality is very much lesser, under 10%. True or false? This is the picture I have taken from Journal for Quality and Participation, and the source is from this. The credit goes to them. So it's true. For the data provided in the table, copy paste and worksheet, please compute arithmetic, mean, median, and all that. So what I will do, I will just open up the mini tab. I have the older version, mini tab 17 version. Opening up this one. All I have to do is I have to copy paste this value. Then we can compute this value as such. So data, the data includes 21, 20, 19, 21, 20, and 19. And then you have 24, 22, 25, 24, 22, 25. And then you have 26 two times, 27, 28, 26 two times, 27, 28 we have. I'm just reconfirming it. Yes. And now what we need to find out basic arithmetic like mean, median, mode, and standard deviation, quartile 1, quartile 3, and all that. So there are two ways. I can go to statistic. I'll just maximize the screen. I'll go to statistic and then basic statistic and store descriptive statistic so that it will store on the screen. And then what I will do, I will just select the data, and all I need is mean, standard deviation, and then first quartile, third quartile, and we need for example range if you want, and then I will give okay. I think we also need a median, so I'll select median also as well, and range may not required, so I will just give okay. Okay, the value got stamped. So 23.8 is a mean, and standard deviation is 3.1, median is 24.5. Let's go to the question. Options. Mean equal to 23.8. Okay, and median is 24.5. So 24.5, that's correct. So this is the one. And quartile standard deviation equal to 3.12. 3.12, yeah, that's right. And then you have quartile 1 20.75, quartile 1 20. Yeah, this is the right. So the first option is right. And here mode also, if you wanted to do, you can also do that. You can give Control E. If you wanted to have mode, you can also do that. Basically mode, if you wanted to have mode, is nothing but repeated value, right? 26 is been repeated, so you can just easily find it out. Okay, and let's go to the next question. Value added example is customer pays for it, does a transformation, do it right at the first time and all. So the answer is all. And the next one is benefit of POCA UK helps reduce the eliminate of formal training program, reduction of the elimination of inspection, reduce or eliminate the rework, all the above. So the answer is all the above. Let's go to the next one. 1.67 sigma, it refers to 5. If the CPK equal to 1.767, it refers to 1.5 sigma as such. And process capability, this is one example. So in this one, we need to tell whether the process is spec within the limit or not. So we can see this is the spec, but we are using this is the limit. You can also see 0.66, that is equal to 2 sigma. Z bench equal to 1.72, that is 1.72 sigma. Process is not capable. Minimum we need to have 1.33 or 1.67 for automotive. So process is not capable to meet the requirement, and more variations may occur. Which control chart we need to use in this scenario? We need to use X bar R chart because you have a more 5 subgroup size as such. Which graphical plots gives this quartile? Box plot gives a quartile, box plot gives a whisker, quartile, median, and so on. And the last question from the multiple choice question, project selection technique include IC, impact, and then cost benefit and efforts, PPA, according to Taguchi, Pareto priority index, impact versus the efforts, all the given option, but not limited to. You have a lot of other options also as well. So now we need to do some exercises. Post a recent promotional ad, bank credit card application increase from 4,500 to 8,000. They would usually have 10% incomplete application. Now it is been increased to 20%. The manager lists down all the reason, help to identify the vital few section, which when we fix will reduce the percentage incomplete application. Which chart we need to use? Because we are talking about vital and trivial, the chart need to use is Pareto. And we need to, they have given the options. This is the data. And this also I will keep it in the drive so that you can make use of it. Anybody who is requesting to have this, I can also give this. So this is the data I have. What I will do, I will just copy this one and paste it in many tabs. So I will just go to file, open up the file, open up the new worksheet and paste this value, and then start, and then quality tools, and then you have a Pareto. In the Pareto, I'm going to select section and frequency, and then give okay. Let's see. Okay, we need to put 80-20%, right? So we can just put this one reference line, and then you have 80%, right? Let's see where the 80% comes. So all of the okay, 1, 2, 3, 4, 5, 6. So maybe I will also will add this another line also as well. Reference line 6. So this is called vital. These are all the issues vital. This is trivial. Let's read the options what we have. So first one is Pareto, that's correct. And the vital is income detail and trivial is PAN number. Let's see. Income details. Income details is one vital. Trivial is PAN one because the PAN comes under beyond 80. Let's see where is PAN. Okay, I think it has been contributed with others. Let me edit this one. I'll make it do not combine. Maybe I will have some visibility. Yeah. So PAN number comes in trivial, right? So therefore, once again, I will drop this chart, go to reference line, and then you give like 80, and then you have 6, and you can give OK. And you can see here, this is vital and trivial, and this one income details. This is the options we had given. Income detail comes in vital. The other things comes in trivial. So this is the right answer. And let's go to another scenario. Mr. Brilliant manufacturer who manufactures the lamp wanted to assess whether or not its process is controlled or not. Sample of lamps were taken every hour for 3 shifts. That means 24 samples being collected of 300 lamps. Perform testing to determine whether or not they work. Defective are lamps that do not work. Now, what are the questions? First one is which control chart to be used. Another leading question is what is the bar value. Another question is look at outlier if anything is there. We also need to find out if 1200 is there, how many defective we may have. We can also need to do a prediction. This is the sample data they have given. Let's go and see in the one the same thing. I'll also will keep this file also as well. This is the defective samples we have. I'm just confirming it whether the same value is same. 1 2 3 5. Yeah, the same value we have. What I'm just going to do is I'm going to open up the new one. I will keep it either I will create a open new one. Okay, I will just paste this value. So now, so this is the discrete one. So go to this one, go to start, and you can go to control chart. You have a something called attribute one, because attribute one, discrete and attribute are same. P value, P chart, and then you have lamps, defective lamps, and then sample size are different. So you can just put like sample size, and then you can find it out, the P value. So P value is 0.173. This is the P value we have got. Okay, let us check in the options. 0.13 is a P chart, that's right. And P chart 0.1373, that's right. Outlier exists? Yes, there is an outlier. Yeah, there is an outlier here. There is an outlier here. There is an outlier exists. That's right. And let's see what is the next clue we will get it. There is an outlier exists. How many defects we will get it? So let's do a calculation. And I will take any of this value. I'll paste this value. Okay. If 1,200 lamps is there, what is the defect? You can just multiply. So P bar value into 1,200 samples being tested. What will it get? So what I will do, I will just round up this value because it's a only defect. So I will just round up. So 16. If we are doing 1,200, we might get 16 defective lamps. So the answer B is the most ideal one because it gives a P chart. P bar P value is 0.0137. Outlier exists. 16 lamp we can do. I'm gonna eliminate all other because there is an outlier here. So this disqualified. U chart no, because U chart is for defect. And then you have a P chart. Again, there is a 165 it says. No, it's only 116 as such. Does weight and weight have any relations with height? And number one, what tool of statistic can be of help? Leading question is what is your wording? So this is the data set I have. All I need to do is we need to tell that what is there are many ways to do it. Let me go and open up the data set. I'm just opening up this file directly. Okay, the file got opened up, and this is the data I have. So we can do various things, correlation we can do, covariances we can do, but I'm trying to see the relationship between those two, those two variables. That's what the question says. So I will say regression with a fitted line. So I'll give F3 so that it will delete it off, and the weight is weight gain and X is height. So I will give OK. And you can see here the R square value is 72. That is moderate, not very 0.8, 80% and above is considered strong. 0.72 is considered is a moderate. So I will go to the question. I will say it's a moderate relation. I will go back to the question. It's a fitted line we have used one of the tool, and it's a moderate one. And then you might also, if you happen to do black belt or green belt, you might get it like the trainer may have a score for teach back, trainer may have a score for the engagement and all that. And then I'm just submitting this answer. Let's see how much marks I have got it. So this is the one I have got. I will be receiving email, and in which the score will be available. Let's go and see that email as such. So yeah, I have got 100 out of 100, and this is the certificate I have got. So thank you so much. I hope